Hello, let's continue the second part of chapter 13. So at the first part of chapter 13, we talk about marginal product, right? We talk about marginal cost, total cost. Then today's class, we'd like to continue to talk about fixed cost, variable cost, and economies of scale, okay? So let's see. Fixed cost, always abbreviated as FC, doesn't vary with the quantity of output produced. So when we talk about fixed cost or variable cost, we related those costs with outputs. Okay, so fixed cost measures the cost that doesn't vary with the output level. So for example, in our previous part of this chapter, we talked about Farmer Jack, right? The cost of the land he need to pay is $1,000 no matter how much he produced, right? No matter the quantity of the outputs of the weight that he can produce. So the cost of the land is always fixed at 1,000, and this is what we call a fixed cost. Other examples like the cost of equipment, the loan payments, the rent, okay, etc. So those are the things that you need to pay every month, no matter you have any output or not. Variable cost, VC, is the cost related to the outputs, or is the cost that will be varied with the output level. So for example, for Farmer Jack, the variable cost will be the labor cost, right? As they hire more and more worker, you can see that the cost of the wages, right? As they hire more and more worker, then he need to pay more and more wages. Therefore, there are also other examples like the cost of the materials. Okay, buy more materials to produce more outputs, then you will involve more cost. So those is what we call variable cost. One thing emphasize, fixed cost or variable cost is thinking about the cost, if the cost will be varied with the output level or not. And the total cost is just equal to fixed cost plus variable cost. Okay? Now from here, you can see we have the fixed cost, right? This is the example shown, you can see from the first column, the output is always 0, right? And then the fixed cost is always like 100. So you can see here we get the fixed cost, okay, the dot here. How about a variable cost? So the variable cost related to the cost will be varied with the output level. So you can see the variable cost. When quantity 0, the variable cost 0. When a quantity increased to 1, the variable cost increased to 70. And when the output increased to 2 units, then the variable cost increased to 120. Remember, this example is not the previous example as Farmer Jack. Okay, this is the brand new example. So based on those information, we can also get the variable cost curve. Okay, so you can see this is the variable cost curve. And finally, we can get the total cost. So total cost is just the summation of variable cost and fixed cost, right? So just need to sum the third column and the second column to get the total cost. So finally, you can see this is the total cost. You can also get a total cost through this table, okay? And pay attention, the vertical distance between variable cost and total cost is actually the fixed cost. And you can see the vertical distance is always the same because the fixed cost is always at 100, okay? Now let's compute the marginal cost. So how we can get a marginal cost? If you still remember, marginal cost will equal to the change in total output, right? Divide the change in quantity. So I can get the marginal cost when a quantity increased from 0 to 1. So I just mark it as marginal cost 1 equal the change in total cost will be 170, right? Subtract 100, right? And then divide the change in output will be 1 subtract 0. So this will equal 70 as it shows on the marginal cost column, okay? And then what about the marginal cost when the output increased to 2 units? Still, we use the change in total cost. So 220 subtract 170, okay? Because 170 is the total cost related to 1 unit, okay? And then divided 2 minus 1. So this will equal 50, okay? And then we can also get a marginal cost when the output increased to 3 units. So we have the change in total cost, 260 subtract 220 divide 3 subtract 2. So this will be 40, okay? So you can see here, this is the way that we compute for marginal cost, okay? And usually marginal cost increases as output increases because of the diminishing marginal product. So you can see at the beginning, marginal cost decrease. However, when you reach the bottom, it increase again, okay? Increase eventually. So sometimes, okay, like in this graph, in this table, marginal cost decrease before increasing, okay? So how can we get a marginal cost curve? So marginal cost curve in this case actually is U-shaped, right? You can see it decrease to the bottom and then increase. Eventually it will increase, okay? Eventually it will increase. So this is the marginal cost. Now let's see average fixed cost. So average fixed cost, when we talk about average, so we'll use the fixed cost to divide quantity, okay? So this is what we get average. So you can think about if the fixed cost is always the same, right? And divide quantity, quantity will increase all the time. Therefore, the average fixed cost should be downward sloping, right? Always decline. So average fixed cost will equal fixed cost divide quantity. So you can see when the quantity equal 1, okay, the fixed cost always at 100, right? When a quantity equal 1, then the average fixed cost will equal 100. When a quantity increase to 2, then we have the average fixed cost will equal 50, right? And then when the quantity increase to 3, we have the fixed cost still at 100, right? But now we divide 3, so we have the average fixed cost. So you can see the last column in this table shows the average fixed cost, and it always declines as more outputs, right? So notice that average fixed cost declines as quantity increases, okay? As the quantity increases. So here we can show you the line for the average fixed cost. You can see the dot showing on this graph always decline, okay? It's showing the decline like this way, okay? Like this way is the average fixed cost. All right, now let's see the average variable cost. So very similar to average fixed cost, we can get the formula to compute average variable cost. Average variable cost is just equal variable cost divide quantity, okay? Average variable cost just equal to variable cost divide quantity. So let's see. When the quantity equal 1, we can get a variable cost equal 70 divide 1, okay, equal 70, okay? And then what about a quantity increase to 2? You can get a variable cost equal 120, right? Divide 2, that will be 60. And then how about the average variable cost when there are 3 units of the output? 160 is the variable cost divide 3, 53.33, etc. Okay? And then we can get the average variable cost when there are 4 units, okay? So similar, okay, you can get 4 units, then will be 210 divided 4, which will equal 52.33, 25. Okay, so 52.5. So you can see from the last column, it shows the average variable cost actually decreases at the beginning until it reach the minimum, right? Until reach the minimum. And then it increases. And then it increases as more outputs, as there are more outputs, right? And then it increases as there are more outputs. So we can say as quantity increases, average variable cost might decrease initially, but eventually it will increase as more outputs. Okay, so here also show you the graph of average variable cost. You can see at the beginning decline, reach the bottom, and then increase finally. Okay, so this is the average variable cost. Okay. Now, finally, let's look at average total cost. Average total cost. So average total cost will just equal to the total cost divided quantity, right? So let me just write it down. Average total cost will equal total cost divided quantity, right? And we can rewrite it a little bit because total cost is the summation of fixed cost plus variable cost, right? Divide quantity. Therefore, we can say average total cost, we can make it like this way, right? We can make it like this way. And this is just equal to the summation of average fixed cost and average total cost. Okay, so this is two ways we can compute the average total cost. Either use the total cost divided quantity or use the average fixed cost plus the average variable cost. Similar. Okay, let's look at this table. When there are no outputs, then we cannot compute average total cost. However, when the output increases to 1, we have the total cost is 170, which means the average total cost here will equal 170, right? When the quantity increases to 2 units, total cost is 220. You use the 220 divided quantity, then you can get the average total cost equal 110, right? Etc. Okay? Etc. We can get the average total cost. It's just use the second column, divide the numbers on the first column. Okay? So you can see very similar to variable cost, to the average variable cost. Average total cost also decline at first until reach the minimum at 5 units, right? And then increase again. So we can see for the average total cost curve, okay, it will decrease to the bottom, right? And then it will increase again, okay, increase eventually. So we can see here the average total cost curve is also U-shaped. Usually, in this example, okay, the average total cost is U-shaped. So this is average total cost curve. Now, let's look at average total cost curve. We have average variable cost curve, right? Look at this two graph. One thing I want to emphasize, okay, I want to emphasize, you can see the vertical distance between these two graphs. You can see the vertical distance between, it's like this way, right? You can see it's like this way. And this is, if I assume this is the average total cost curve, okay? And this could be the average variable cost curve. You can see the vertical distance between these two curves declines or becomes smaller and smaller. Why? This is the average variable cost curve. This is the average total cost curve. What's the difference between these two? ATC minus ABC will actually equal to average fixed cost, right? And average fixed cost, as I'm talking about here, this fixed cost is always fixed, right? Divide quantity. So it will decline all the time, right? It will decline all the time. And this will just verify through the vertical distance through these two graphs. You can see the vertical distance between average total cost and the average variable cost declines as more outputs. And then this is the average fixed cost curve, always decline. And then finally, we'll have our marginal cost curve. So marginal cost curve will eventually also increase, right? So this graph, very important for this chapter, okay? Now this is the example. Would like you to compute the average, to fill this table, okay? To fill this table. How you can do that? If I have this tables in the practice question or in the exam, the things I would like to fix first will be find out the fixed cost first. Find out the fixed cost first. Because the first column shows the quantity, right? The second column shows the variable cost. The third column shows the total cost. So I can get the fixed cost easily. So here, look at the fixed cost, which just equal to the total cost to subtract variable cost, right? And then look at the fourth, when an output equal 4 units. When output equal 4 units, okay? We have the variable cost equal 100, right? We have total cost equal 150. So can you get a fixed cost now? Fixed cost is just equal total cost subtract variable cost. That's 150 subtract 100. We can get 50, right? We can get a 50 as the fixed cost. So this can be get immediately, okay? You can also get the fixed cost through the average fixed cost curve, okay? Through average fixed cost. So you just need to use the fixed cost times the quantity. Also, you can get a fixed cost. Then, if we have the fixed cost equal 50, it will be easy for us to get the variable cost, right? Because the variable cost is just equal total cost subtract fixed cost, right? So it will be easy for us to get the first rank, okay, showing you can get the first one showing 0. Why? Because there is no output, which means no variable cost, right? And after that, you already know the fixed cost. You can just use it divide quantity to get an average fixed cost, okay? So after that, you can get a total cost. You can get all the total cost part, right? And then you can get the average fixed cost equal to the fixed cost divide quantity to fill all the average fixed cost. So you use 50 divide 1, you use 50 divide 2 to get average fixed cost equal 25, right? And then you use average fixed cost 50 divide 5 units, then you can have 10, right? So here you can fill out all the average fixed cost. Then how can you get average variable cost? Average variable cost would just equal variable cost divide quantity, right? And you can just use the second column, divide first column. Divide the first column to get the average variable cost. So for example, when the quantity equal to, when a quantity equal to variable cost equal 30, right? So here you can get average variable cost equals 30 divided 2, you can get 15, right? And then you can also see when quantity equal 4, we have variable cost equal 100. So you can get the average variable cost equal 100 divided 4, that will be $25. Okay, so here you filled out average variable cost. And finally, you can get the average total cost. So how we get average total cost? Average total cost is just equal average fixed cost plus average variable cost, right? So you can, based on average fixed cost and average variable cost, and then to fill out average total cost. And you can also get a marginal cost, right? Because marginal cost is just the change in total cost divided change in output. So for example, when a quantity equal 2, we have the total cost equal 80, right? So use 80 subtract 60 to get a change in total cost equal 20, and divide 2 minus 1, that will be get 20 for the marginal cost, etc. Okay, you can get the total cost. Okay, you can get the total cost using, how you can get a total cost equal 110, because the total cost will equal to average total cost times the quantity. Okay, and then when quantity equal 3, we have average total cost equal 36.67. We use that times 3 to get total cost equal 110. Okay, so similar, we can fill up all the marginal cost. Okay, we can fill up all the marginal cost. Finally, we can get the average total cost. Okay, so average total cost can equal the summation of average fixed cost and average variable cost, or you can just use total cost divide quantity. So finally, you can fill out this table. So the way to fill up this table is important because you need to use those formulas frequently. Okay, and this type of their practice question, this type of their questions will be appeared in your practice question, your exam questions, or even your homework assignments. Okay, the quizzes. All right, now let's look at why average total cost is always U-shaped. You can see here, as quantity increase, initially we have the decreasing average fixed cost, we have the decreasing average variable cost. So it will drag the average total cost down. Eventually, we have increased average variable cost, right? And that will actually pull up the average total cost curve. This is why the average total cost curve is always U-shaped. And then we will talk about economic scale. Okay, so economic scale will related to the quantity that can minimize average total cost. So look at this one. Look at this two graph. This is the quantity, okay? This is the quantity, and this should be the cost. Average total cost. This is the marginal cost curve, okay? So as far as we know, that marginal cost curve will always intersect at a minimum point. So this will be the minimum point of average total cost, okay? Marginal cost curve always intersects at a point with the minimum average total cost. And you can see at the beginning, okay, I will divide this one into two parts. I will divide this graph into two parts. You can see from this part, marginal cost smaller than average total cost, right? Because marginal cost curve is below average total cost and average total cost decrease as quantity increases. Make sense or not? Decline, decline. Because this at this part, average total cost is still always above marginal cost. Okay, therefore we will have this conclusion. We will have this conclusion. As output increase, the average total cost still decline. Okay. However, you can see in this part, what happens? In this part, we have marginal cost now is above average total cost, right? Is already above average total cost. And then we have average total cost increase as output increase. Make sense or not here? You can see from this graph, okay, it divides through this minimum point, it divides this graph into two parts, okay? On the left-hand side, we have the average total cost always above marginal cost, and which means at this part, marginal cost will decrease as output increase. However, on the right-hand side of this minimum point, we have this marginal cost above average total cost, and it tells us as more outputs, then the average total cost will increases. So it's that when marginal cost is smaller than average total cost, then average total cost decline. However, when marginal cost larger than average total cost, then average total cost is increasing. They intersect at a minimum point of average total cost. So for example, if you run a pizza store, okay? And then you are producing 100 pizzas per night. Your cost of the pizza average, okay, $3. The cost of producing one more pizza is $2. Then, if you produce this pizza, what will happen to the average total cost? So look at this question. You have the average total cost of the pizza is $3, right? And then you also notice that the marginal cost of producing one more pizza is $2. So what happens? This $2 here is still smaller than average total cost, right? So if you're producing this pizza, the average total cost will decrease, right? If the cost of the producing one more pizza now, in the second case, marginal cost now increased to $4, average total cost is still at $3, then in this case, we have marginal cost already larger than total cost. Therefore, producing this pizza will actually increase the average total cost. Okay? So let's see. In the first case, average total cost will decline. However, in the second case, average total cost would increase. Okay, so this is just based on this graph. Now, show you again about those four different graphs, okay, in this chapter. So if you need to draw the graph in this chapter, I can show you some way, okay, to be a little bit easier to draw this graph. So how to draw this graph more accurate? This is Q, okay, and this is the cost. First, you need to draw an average total cost curve. So this is what you first can do. You can draw this as average total cost curve, okay? And then what you need to do is draw the average variable cost curve. Average variable cost curve. You can notice these two curves, the vertical distance decline as quantity, okay, increases. So this is two curves. And then you can, after you draw these the two curves, then you can add marginal cost curve. So marginal cost curve, first you need to mark, this will be the minimum. Okay, this will be the minimum of average. This will be the minimum of average total cost. And this could be the minimum of average variable cost. Then the cost curve. Then the marginal cost curve, okay, will like this way. This will be the marginal cost curve. It will intersect at a minimum point of both average variable cost and average total cost. So here you finish the three curves. Marginal cost curve, average total cost curve, and average variable cost. Then finally you can add the average fixed cost. It will always decline. Average fixed cost always decline. So from here, you just draw these four different curves, okay? And this graph is very important. Marginal cost curve eventually will increases as more outputs, and the average total cost curve and average variable cost curve always U-shape, okay? U-shape, U-shape. Marginal cost curve increase or intersect, okay? Will intersect with the minimum point of average total cost curve and average variable cost curve, okay, as I show in here. Okay, so let's look at the last topic, how to measure the cost in the short run and cost in the long run. So in the short run, some inputs are fixed, right? And those costs are related to fixed cost. However, in the long run, all the costs will be variable. Okay, so there is no fixed cost anymore in the long run. So in the long run, average total cost at any quantity is the cost per unit using the most efficient mix of inputs for that output. Okay. Now let's look at some conclusions and summaries. So costs are critically important to many business decisions, including production, pricing, and hiring. And in this chapter, okay, we introduce different types of cost, okay? The next chapter, chapter 14 and chapter 15, we would like to talk about how firms will use those concepts to maximize profit in different market structure. Okay, so for example, in perfectly competitive markets was the market decision. In a monopoly market was the market decision. And let's look at the summary, okay, of this chapter. At the beginning, we talked about two different types of the cost, right? Implicit cost, explicit cost. So implicit costs do not involve a cash outlay. And but it's important, is as important as the explicit cost, especially after you learn economics. You should know the accountant will just tell you the accounting profit, but for yourself, you also need to learn about the economic profit. Accounting profit is just the revenue subtract the explicit cost, and economic profit is the revenue minus all the cost, including explicit cost and implicit cost. The production function shows the relationship between outputs and inputs. We talk about the marginal product, right? And then in this chapter, we only focusing on marginal product of labor because we assume capital is fixed, right? And marginal product of different inputs are very similar. It has a very important characteristic is marginal product is always diminishing eventually, okay? So we say marginal product usually diminishes as input increases. And we'll also talk about different type of costs, including fixed cost, including variable cost. When we talk about fixed cost or variable cost, we related those costs with outputs. Marginal cost is the change in total cost divide the change in output. So marginal cost curve is usually upward sloping. Sometimes it might also U-shape at the beginning, reach the minimum, and then it will eventually increase. Average variable cost is the variable cost divide outputs, and average fixed cost is just the fixed cost divide output. Average total cost is just the total cost divide output. So you can see for these three average, either average variable cost, average fixed cost, or average total cost, we all use the related cost divide quantity. Marginal cost curve intersect the minimum point of average total cost curve, okay? And for that part, we divide the average total cost divide into two parts, right? When marginal cost is smaller than average total cost, we notice that average total cost will decrease as more outputs, right? However, on the right-hand side of that minimum point for the average total cost, we notice that marginal cost larger than average total cost, and average total cost will increases as output increase. In the long run, all the costs will be variable. Okay, so I think that's the end of chapter 13. In this chapter, remember more formulas you need to remember to compute those different type of a cost, and this graph, it's very important. Thank you so much.